Now, here's the other thing you need to know about asteroids. They're very, very black. Their albedos, or how much light they reflect, is typically under 10%. That means they're like charcoal. And they're very, very difficult to spot from the ground. But that makes them glow in infrared. So this is what the infrared sky looks like. Again, these are all real orbits. That's the infrared background sky from the WISE spacecraft. And we put this in its final orbit, and we've done the full simulation. And all the objects that are moving are asteroids. So what this thing is going to do is take repeated images of the sky in infrared and look for the moving objects, because those are asteroids. We'll catalog them. We'll throw together that other three-dimensional map, and it'll be real now. It'll be all real data. What you can do from that is that means that you will know what the trajectories and locations are of close to 1 million near-Earth asteroids. And that means that we'll know if any of them is going to hit the Earth, and we'll know decades in advance. And that means that the job of deflecting them is actually relatively straightforward, because we'll know where they are. So let me just show you a little bit about how that looks. Here is our spacecraft called Sentinel. There's the Earth's orbit. This pi is roughly the region that it can see. So look, it will map all the asteroids in that sort of pi wedge. As it moves around the sun, you see it will sweep out Earth's orbit. Over 6.5 years, it basically finishes all the mapping of all these asteroids in this region here, larger than, it'll be very complete at sort of the 140-meter level. It'll be mostly complete down to the Tunguska scale. And that's what we're trying to do. So now let me get to the part about what's sort of innovative about the way we're doing it. So I was giving this talk about 1.5 years ago over at Google. And I was explaining the fact that we know the locations of, we're in this strange situation. We know how to deflect asteroids, but we don't know where they are. And we don't know where they are because we haven't looked. And I was saying, well, it's kind of crazy. NASA was actually directed to find the largest of the asteroids, a kilometer and larger, which they've done a great job of doing. They've been directed to find the smaller ones, but never funded. And it's a continuing budget fight in Washington, and there's really, it's just not going to happen. We can discuss that later, why exactly that is. But we're not looking for the smaller ones, and we think we should. So some guy comes up to me afterwards at the end of this talk, and he goes, how much would it cost to build that telescope you're talking about? I said, oh, well, perfect world, if we could build it any way we wanted, because we know kind of what you want to build. Very similar to the Kepler Space Telescope, infrared, 50-centimeter optics. We kind of knew all these parameters. I guessed a few $100 million. He goes, oh, that's interesting. He goes, why don't you just go and build it? He goes, well, let me tell you what I mean. He goes, I just donated to the California Museum of Modern Art. It's up near Moscone Center. He goes, we're building a new wing on the museum. The museum's been there for a while. And aside, my sister actually worked on that construction project. The new wing cost $500 million. He goes, the people of San Francisco are going to donate money, and they're going to build the wing of an art museum for $500 million. He goes, so can you get the people of the world to raise something less than that to save the world? Think about that. So we decided that was going to be our mission. I mean, as the more we dug into it, the more we realized how common it is that groups raise several $100 million. I mean, it is a lot of money, no question. But it's actually fairly common. Anybody been over to the new Bing concert hall here? Just opened up, right? $120 million roughly. Okay, supplied by alumni. Okay, it's a concert hall. I'm talking about saving the world, okay? All right, the California Academy of Sciences Museum. Beautiful museum, $505 million. Business school building over here, supplied by alumni, $350 million. Okay, so it's in the range of building an academic building. So we set out to build a team. One of the first people I talked to was Scott right here, because Scott's he's a very modest guy too. He is one of the most knowledgeable people in the world about how to run spacecraft programs. He showed this with basically rescuing our Mars program. Thank you very much. We had lunch just down the street over there. You remember, right by California Cafe. And I said to Scott, in a perfect world, how would you run if you could run a spacecraft program any way you want, and you remember what you said to me, you said, well, if I knew the requirements were stable, we would set stable requirements. I would handpick a very, very small team. I would get a contractor and sign what's called a firm fixed price contract, which they can do if we understand exactly what we're going to build and they're confident we're not going to change it. And, and we'd move fast. And I said, well, that's what we're doing. How'd you like to join us? We made that same pitch to Tom Gavin at Jet Propulsion Lab, Harold Reitzema, formerly with Ball Aerospace, the company that built Kepler, and is going to build Sentinel, and a number of other people. We built our small but excellent team. And we turned out we decided that we did need NASA's help. And we've partnered with NASA, and NASA is going to provide the tracking and communications, the data transfer from our spacecraft. So what's called the Deep Space Network, all the communication will happen via NASA. And NASA is also equally important, allowed some of their people, some of their experts, to sit on our review teams, make sure that we're going to do this right. So we're pioneering something which is in between the pure, from a funding level, we're a nonprofit. Okay, 501c3 tax deductible donations, that whole thing, just like the guys building an academic building. On how we're running it level, we're running it more like a commercial procurement with a really smart team buying it. Okay, and again, we launched in 2018. Our facility has now just had its grand opening. That's where the high bay where our spacecraft is being built. We've already begun work on the infrared detectors. It's a big detector about yay big, which is huge. That has been fabricated. It's been chilled to its 40-degree Kelvin operating temperature. We've been through our first major review, and we're gathering donors at a fairly good clip. So, it's moving along. I mean, in the end, let me kill this thing which is sitting here replaying over and over. What's it all about? I think we're at an interesting time because we've reached the point where a private organization could even consider going out and doing this, right? And why is that? Because there is launch capability that we can procure. We're going to launch on a SpaceX, wherever John is, thank you very much, a Falcon 9 launch. There have been big improvements in infrared detectors in the last few years, big improvements in onboard computing in the last few years, and frankly, a lot of improvements in the way we do business. John mentioned the guy calling in from his VoIP connection online. We are project-based. The B612 Foundation is a virtual organization. We have people scattered around from Denver to here to Los Angeles to the East Coast. And we're not spending money on building ourselves a headquarter building. We're running a project. We intend to exist for 12 years. We intend to make this map, which, by the way, is good for about 100 years because the orbits are stable over roughly that time scale. We're going to give this data away. We're going to put it online as our gift back. And we're doing this just because we think it's the right thing to do. I mean, I've been blessed to have had a chance to work with great people and get to do some amazing things courtesy of the U.S. taxpayer. And then I got to come out to Google and learn a lot there. And now I'm at the point where I've decided, hey, what's the most important thing I can be doing? And this is it. If you are lucky, in your life, you get maybe one chance to do something that changes the world. And I feel like I've gotten lucky. And what we're doing is we're gathering people who want to join this, who want to take part in this. And you can. It's kind of interesting because of the fact that we're a membership-based organization in some sense. You can just donate and join up, take part. And that's what we're doing. So, especially for students out there, there's some interesting things going on that are it's public-private partnership. And literally, I think we're going to change the world. Hopefully, that, when I said 30% chance there's something that's going to hit the Earth in the next 100 years, hopefully we're in that 70%. But if not, I want to know about it. I want to know when, where, and I want to do something about it. So here's the really interesting thing. We're actually talking about not just changing our planet, we're talking about changing our solar system. From this point forward, the third planet from the sun should not be hit by another large asteroid. That's kind of profound, huh? And it is because a group of people here, here in Silicon Valley decided we're going to do something about it. And so I'll take whatever questions you got.